Hey everyone, hi, welcome to askIITians. So this is lecture number 3 of statistics, grade 10. Yes. So in the previous classes we have talked about a couple of things. That is, we have talked about various methods to find mean, and in the previous in the last to last class, that is in the first class, we had talked about how important this chapter is from board's perspective and the how is it related to our lives in day to day perspective, right? So today we would be talking about, basically we would be continuing this chapter, right? And we in the last class, as I said, we had discussed the direct mean method, the assumed mean method, and the step deviation method, right? All these things we had seen in the last class. So today we would be talking about mean of continuous frequency distribution. We would be continuing that thing, mean ka thing, and we would also be talking about a new thing, that is sum of deviations from mean. So we know already what do you mean by deviations, and what is it regarding. So we would be talking about that, right? So let's quickly start. What do we mean by mean of, how do we calculate mean of continuous frequency distribution? So we say in a frequency distribution of continuous type. Now what do we mean by continuous type? So continuous type matlab जिसके class intervals are continuous. For example, the class intervals are in the form of 10 to 15, 15 to 20, 20 to 25, and so on, right? There is no gap between the upper limit of the previous class and lower limit of next class. There is no gap between upper limit of previous class and lower limit of next class. दोनों equal है, same है, no gaps. So in that case we say the frequency distribution is continuous. ठीक है? So how to determine the mean of these frequency distribution which are continuous? So we would say, since we have already known by direct method, the mean of the direct method formula, or the formula for mean, is sum of all observations upon number of observations, right? So here again you would say, instead of like what was the formula there in grouped frequency, the x bar was summation of fi into xi, which we had seen in the last class, summation fi xi upon summation fi, right? This is what we had seen in the last class. Now in continuous distribution, just xi ke jagah pe we write it as mi, right? Fi mi upon summation fi. Your summation fi is again the number of observations, right? And how do you calculate xi? Xi was a midpoint of the class intervals, right? So here also your mi are the midpoint of the class intervals, right? 10 to 15, 15 to 20, like these. So this formula is applicable if and only if the frequency distributions are continuous, right? So let's now understand this. We have to find the arithmetic mean for the following continuous data, right? So here it is given that the frequency distribution is continuous. That is, you all can also see that this is 0 to 10, 10 to 20. So here it is ending at 10, starting at 10, ending at 20, starting at 20, ending at 30, starting at 30. Right, and this is the frequency distribution. So first we would calculate the midpoints. So midpoints are like 5, 15, 25, and 35. So it's very simple, summation fi xi upon summation fi, or in this case summation fi mi upon summation fi, right? So midpoint m here is 5, 15, as I said, and frequency, so summation fm is 15, fi is 15, and summation fi is just 11. So just dividing both of them, we get 19.54. So you all will tell me, okay, so this is what we had learned in the last to last class as well. That is, maybe we had talked about direct method, calculation of mean using direct method. What is so different in this? So that is where we come to now. That is, if you are given a frequency distribution, let's say, which is not continuous. For example, you are given a frequency distribution which is like 10 to 19, then the next one starts with 20 to 29, and the next one starts with 30 to 39, and 40 to 49. Now you all can clearly see that this one ends at 19, but the other one starts at 20, not at 19. So in this case, the distribution is not continuous, right? So can we find the mean directly You would say no. First we have to make it continuous. So how do we make it continuous? Let's see. So what is the difference? Why are we saying that it is not continuous? So you would say this is ending at 19 and this is ending at 20. So there is a gap of 1. There is a gap of 1, right? So you would say if there is a gap of 1, distribute zero point 0.5 to the previous class, zero point 0.5 to the preceding class, right? So you would say distribute half the gap to the preceding class, half the gap to the preceding class, and half to the succeeding class, half to the succeeding class. So in this case we would say the gap is total of 1. So zero point 0.5 will be given to 10 to 19, which means your now revised intervals would be 9.5 to 19.5, because you need to increase this by 0.5, and you need to increase the preceding class by 0.5, you need to decrease the succeeding class by 0.5. So this would become again 19.5 to 29.5, right? Because again this would become 29.5 to 39.5. This would become 39.5 to 49.5, right? Because this one is being distributed zero point 0.5 to this and zero point 0.5 to this. This is how you make a frequency distribution which is not continuous. You make it as continuous by distributing the gap equally among the preceding class and succeeding class. It's as simple as that. So now for those who want one more example, yes, I am sure that few of you all will need one more kind of this example. So if I give you like maybe 15 to 20, 21 to 26, 27 to 32. Now if I ask you to make it continuous, so you would say distribute 0.5 to this and 0.5 to the other one. So you would say this would become 14.5 to 20.5, right? And this would be 20.5 to 26.5, and this would be 26.5 to 32.5, right? So in all the cases you make it as continuous distribution. Now right now every time the gap need not be of 1, right? The gap can be more than 1 also. So if the gap is 5, let's say, like 15 to 20 के बाद 25 to 30 है, so you would distribute 2.5 to the previous class, 2.5 to the succeeding class. This is how it's simple, right? So after making it continuous, you just need to do the same thing. That is, we would be finding the midpoints, that is the class marks, multiplying them by the frequency, and get summation fi mi upon summation fi will give us the mean, right? I hope everyone's understanding. It's the same procedure after making it continuous. Absolutely correct. Yes, very good. 19.54 is the answer for this one. Yes. So next thing we have to talk about is mean deviations from mean. That is sum of deviations from mean, which means deviations means what? See, why do we need to study these deviations? Because we need to understand how far our observation is away from the average observation. This is what the significance is. Why do we calculate mean? So that if we have a data, if we have the data of 100 students, we should be able to represent that data of 100 students by a single parameter, right? By a single parameter, by one observation. So you would say calculate its mean, and you would say the average of 100 observations is this. The average of 100 students is this. That is the mean. But now you also need to analyze, after finding the mean, you also need to analyze that how away is your observation from the mean observation, from the average observation. So in that case you would say, if your let's say the data for 100 students ka average is maybe 50. So for each observations were like maybe 5, 8, then maybe 49, 55. So all of these were observations. So you would say this 5, and there were many more observations obviously, since we are talking about 100 students. So you would say that for 5, that is, this 5 is 45 units away from the mean, right? This is 5, 45 units less than the mean. So for example, if these are the marks of those students, अगर ये marks है, तो you would say this student has scored 45 marks less than the average marks scored by the 100 students. This student has scored 45 marks less than the average marks scored by 100 students, right? So this is how important mean deviations is. Mean deviation means how every student is performing with respect to the average marks, with respect to the average student. So some students, for 55, you would say this student has scored 5 marks more than the average student, right? Or more than the average marks. This is how it will, this is how you will analyze the performance of each and every student with respect to the average student, with respect to the mean deviation, right? So sum of deviations from mean. So now you would say, if you want to calculate the sum of all those deviations, so what do we get? So this was, the deviation was minus 45. For this case, the deviation would be 8 minus 50, that is minus 42. And similarly, this would be minus 1, and this would be plus 5. So for all of these, if you take out the sum, right, let's see. So you would say, acha, there would be more, there will be total 100 observations. We are just considering only these 4, right? I had just given you an example for this, but there would be 100 students, basically 100 data, 100 marks for each and every student. Okay. So then we have, what is the formula? You would say sum of mean deviations would be summation of xi. Xi is your every observation, and x bar is your mean. So summation of xi minus x bar. Summation of xi minus x bar. So he's saying prove that the sum deviation from mean of this 3 4 6. So you would say first find the mean, because then and only then we would be able to find its deviation. So you would say mean is sum of all observations upon number of observations, right? So what is the sum? You would say 3 plus 4 plus 6 plus 8 plus 14. How many observations are we talking about? 5, right? So this is giving you 10, 10 and 3 13, and 14 is 27, and 8 is 35. 35 divided by 5 is 7, right? So we are getting the mean as a 7. So now we would be trying to calculate the mean deviations, that is how each observation is away from the mean observation. Okay, how much each observation is away from the mean observations. So we need to calculate the mean deviations. Okay, so we would say the first observation is 3, तो ये हो जाएगा 3 minus 7, कितना है ये? minus 4. Next observation is 4, right? 4 minus 7, this is minus 3. Then 6 minus 7, minus 1. 8 minus 7 is 1, right? Then 14 minus 7 is 7, right? So these are the mean deviations. These are the mean deviations about mean. Okay. Now you would say if these are the mean deviations about mean, you need to, if you need to find the sum of all these mean deviations. So what do we get? Let's see. So if we are now trying to find the sum of all, because he's saying sum of mean deviation, some deviation from mean. So sum of mean deviations would be, let's add. So we would get minus 4 minus 3 is minus 7, minus 1 is minus 8, and minus 8 plus 8 is 0, right? So we are getting the sum of all the mean deviations is 0, and this is supposed to happen every time, guys. Tell me why? Because we know if we are finding the deviation about mean, तो mean मतलब mean आया कहाँ से है? Mean भी तो sum of observations में से ही आया, right? Mean we have got from sum of all those observations. Now if you are taking every observation and saying that its deviation from the mean is negative, so some observations will have the deviation negative, and the remaining observations will have the deviation as positive, right? And when you add all the deviations, you are supposed to get 0, because the total sum you have got it from the mean itself, right? So you would say the sum of deviations from the mean is always 0. This will always be the case, as it is a property of sample mean. That is, if you are considering mean of 50 observations, right, 25 of them will be negative mean deviation and 25 will be positive mean deviation, which means that the total mean deviation about mean will always be 0. The sum of deviations below the mean will always be equal to sum of deviations above the mean, right? Above the mean. So here the observations above uh, the mean was 7. The observations above the mean were 8 and 14, right? Unka deviation kitna hai? Total 8, right? You all can see total deviation is 8. And if you see the sum of observations, how many observations were there below the mean, below 7? There were these 3 observations which were below the mean, 3, 4 and 6. Inka deviation is minus 8. So sum would be negative 8 plus 8, which is 0. So this will always be the case. That is, you would say sum of deviations from the mean is always 0, right? Mean deviation is always 0, right? So this is what we wanted to discuss in today's class. And we also talked about continuous distribution. Yeah, so this is what you can see that the mean was a 7, and we calculated its mean deviation and added, we got minus 8 plus 8 as 0. So yeah, this is what, these are the things which were supposed to be discussed in today's class. I hope you all understood a concept of mean deviation, and also the concept of mean, finding mean in a continuous distribution, right? In the next class we would be talking about how to calculate median, and how to calculate median for grouped, ungrouped, and mode for grouped, ungrouped frequency distributions. Till then, take care, stay safe, enjoy, and have fun. Bye bye.